Hello, my name is Tan Jingshan, battery number 330393, and this is our introduction. Ever wonder how your phone knows exactly where you touch? It's all thanks to electrostatic field governed by the Laplace equation. Capacitive touchscreen use conductive material like indium tin oxide. When your finger touches the screen, it changes the electrostatic field. The device detects this to find the touch point. The Laplace equation, second derivative v equals to 0, helps model these changes. It ensures accurate touch detection and support gestures and powered innovation like foldable screen and AR. As screens advance, these equations stay key.
Have you ever wondered how your touchscreen works? Your screen not just a piece of glass. It's layered with invisible electrodes that creates electric fields. Your body has tiny electric charges, including your fingers. So when you touch the screen, the electric charges on your finger causes disturbance on the electric field, and the system detects exactly where the touch has occurred and boom, that's your touch point. So basically, your body is a part of the circuit. If you want, you can try this. Take a non-conductor. For example, take a pen and try to use your phone and tell me whether it can work or not. Thank you.
My name is Siti Nasifa Husna and my magic number is 227855. I will introduce the topic that has been chosen from our group based on the real-life phenomenon involving the PDE, which is the electrostatic potential in smartphone touchscreens using a Laplace equation in real life. So have you guys ever wondered how our phones knows exactly where we touch it? Actually, that's because underneath the glass there is an invisible electric field and our finger has disturbed it by touching it. So the capacitive touchscreens detect our finger by sensing the changes in the electric field. So whenever you touch the screens, our finger will disrupt the smooth voltage across the surface. So this electric potential can also be described by Laplace equation, which is del squared V equals to 0, or also known as the Laplacian of V equals 0, and the alternate form is second partial derivative of v with respect to x plus the second partial derivative of v with respect to y equals to 0. So here the v is the electrostatic potential or the voltage at each point on the screen. So it models how voltage spreads smoothly when there is no change, there is no charge. So what can cause the charge, which is our finger. So whenever you touch the screen, you will disturb the electric field, and the touchscreen system will detect the changes using the Laplace equation to figure out where you touch on the screen. So even though you don't see the math, actually our phone has been solving PDE every time we touch.
My name is Nikliana Alia binti Iskandar and my metric number is 230303. So next I will proceed with the next section, which is boundary or initial conditions in a smartphone touchscreen. So as you guys can see, this might look just like a normal smartphone, but inside the screen there's this thin layer that senses where I touch, and that's possible because of something called electrostatic potential, which is described by a partial differential equation or PDE. Now let me show you how this works using a visual. So based on the diagram that I include in this slide, as you can see, in this picture, you can see that small voltages applied to the corners of the touchscreen, and in this, these little small voltages are actually kept constant. So we call that a Dirichlet boundary condition. Now, just like in the diagram, the edges of my phone screen here, is also held at a constant voltage. So that will create a stable electric field before any touch happens. So we call this the initial condition. Now, when I touch my screen, my finger disturbs that field. So just like in the diagram that I provided in the slide, where as you can see, the grid bends. Now that change in potential is what the controller detects to find my touch. So basically, the math behind touchscreens really relies on the boundary and initial conditions in a PDE. So even though we can't really see it happening, our phones are actually solving equations every time we tap the screen.
Hi, my name is Putri Alisha Barkis. My metric number is 230095. So, to conclude, partial differential equation or PDEs play a very important role in science and technology. They help describe how physical things like electric potential, heat, or pressure change across space and time. In our case, smartphone touchscreen, we use the Laplace equation, which is a type of PDE. It helps model how the electric potential on the screen changes when we touch it. So by solving this equation, With the right initial and boundary condition, the screen can accurately detect where we touch. PDEs also help engineers design better and more advanced screen features like multi-touch, foldable display, and even augmented reality. But their use goes way beyond just smartphone. PDEs are also applied in physics, biology, environmental science, and many other fields. So, as our technology keep improving, PDEs will continue to be an essential tool in solving real-world problems.